Hi guys, welcome back to my channel. Today we want to look at how to tackle a difficult question under logarithm using the simple law of logarithm. You see, many students they find it difficult to analyze logarithm questions, such as this kind of question here. If you are given this kind of question in this case here, how do we solve it? It is quite simple. We can simply apply the simple law of logarithm. Before we start this class, I'd like you all to please subscribe to my channel and also click on the like button to like my videos. Thanks. Let's get started. Now, I have a question on the board. We are given different laws, or let me say the question has different laws of solving it. For example, we have 81, which is serving as a base here, which is equals to 1 over log of 9 base 5 plus 3, which is serving as a base here, all over 3 over log of 3 root 6 into brackets root 7, 2 over log of 7 base 25 minus 1 with 125 into log of 6 base 25. How do we go about this? You see, the first thing I need to do in solving this kind of question is to break the logarithm down into the lowest, or let me say into the simplest formats. If you check here, the logarithm we are about to solve is acting as a power. It's serving as a power here, while the number is the base. So the first thing, we can apply simple law of change of base of formula. Now, there is a law in logarithm. We normally call it change of base formula. In change of base formula, we know that if I can convert a logarithm from one base to another base. For instance, I have a log into log A base B can simply be solved by converting into, I can convert this base B into base A. Now, the simple formula for it is log A base B is always equals to log B base A. 1 over log B base A. That is one simple law of logarithm. Many people do not understand that there is a law known as change of base of formula. Now the second law that is there, if I have a power in logarithm, such as this, let me assume I have A raised to the power logarithm of base A into x. You see, this law is always called if the base here and the base of the logarithm is equal, and I can apply this, then the law states that if I have such thing like this, a raised to the power log of x base A, your answer should be equals to x. These are the two basic laws that I want to apply in this case here to solve this kind of question. It looks difficult, but it is quite easy and simple. Now, let's come back to it. Let me try to put it somewhere else here. I have log of A base B, log B base, or let's say log B base A equals 1 over log A base B, and the second law is A raised to the power log of A raised to the power x should be equals to x. Now let's take it one by one. If I check this question here, you notice I have something of 1 over log 9 base 5, and I have 3 over log 3 base root 6. And I also have 2 over log 7 base root 25. How can I go about this? Come to this place here. I have 81 here. I can simply express 81 in terms of 9. 3 can be expressed like this. That means I can easily drop down this equation applying the change of base formula. If I apply the change of base formula in this, I'll be having 1 over log, that means my 1 over log 9 base 5 using change of base should be equals to log 5 base 9. That is number 1. In this case here, this thing here is 3 all over log, what we have here is 3 all over log 3 root 6. I can simply express this as 3 multiplied by 1 over log 3 root 6. If I express this like this, then I can simply say that this 3 over log 3 base 6 can be, if I change this using the change of base formula, I should be having this one to be giving me 3 times log of base 3 root 6. That is 3 log of root 6 base 3. I've been able to convert this back. Now the next thing that I need to do is for me to convert this. The same way I did this, I'll also do this like that. That means my 2 all over log 7 base 25 should be equals to the same as this, which will be equals to 2 log of base 7 log 25 base 7, which is this. Now, I've converted this back. The next thing, I apply this single log here to convert all this fraction into a single log. This is log of this. This one represents, 1 over log 9. I think I have it here. This is it here. 3 over log this. I have this. Then 2 over log 7 base 25. This is it. Now I can simply substitute into these equations. If I substitute here, in this place I have 81, right? Instead of this, I should be having log of 9 base 5. Log 5 base 9 plus 3. All this should be giving me 3 log root 6 base 3. And then I should be having into brackets multiplying all this. This one should be giving me root 7. Then all this I'll be having 2 log 25 base 7. Log 25 base 7. Then I should be having this one as minus 125. Minus 125 log 6 base 25. Open sense to this sake, we have 81 log 5 base this and this. I've applied this simple law to convert this fraction into a single log. Then I can simply apply this law here that whenever I have a log x base a should be equals to x. But how do I convert this? It simply means the base of the log and this base should be equal. If I check here, the base of the log is 9, the base here is 81. How do I convert this to 9? Quite easy. Just go straight. Since 81 can be written as 9 square, don't forget that this thing is serving as a power here. So if I have 81 to be equal to 9 square, that means everything raised to power of log of 5 base 9. Now, the same thing goes to this place. This is already 3. The only thing I need to do here is to transfer this back to this. I'll be having log of 3. There's a log of logarithm. Log of logarithm has said that if I have something of this kind, a raised to power x raised to power n, it can simply, log a raised to power x raised to power n can be written as n log a raised to power x. That means if I have something of this kind, I can return this n back as power to be like this. Whereby I'll be having this one here as log of 3 root 6 raised to the power of 3. I'm going to be having something of this kind. Now, into brackets, this is root 7. I can simply write this myself as 1 over 2. That is the power. All this is serving as a power. Everything into brackets, 2 log of 27 base 7. Now, minus of this one can be written as something of this kind. You see, I want to make sure that this base and this thing are equal. I can easily apply simple rule. I can write them in terms of 5. Because there's no I want to multiply 25 that's going to give me 125. The only thing I can do is just saying 5 raised to the power 3. Now, everything into brackets, log of. Now, this 25 can be written as 5 squared, still raised to the power 6. But this 6 is having a power of 1. Yeah. There is a law of logarithm that says that if I have something of this kind, you have log of, let me say, x raised to the power a raised to the power n raised to the power n. He said, you see, this x here is the base. The base is carrying the power of a. This is the log. It is carrying the power of n. then the rule states that whenever you have such thing like this, then the power of the log divided by the power of the base should be used to multiply the log. That means I should be having n over a log of s raised to the power of m. I think I have such kind of thing here. This is the base. This is the power of the base. This is the log. This is the power of the log. I can simply use this to divide this. Whereby I will now be having, if I apply the log, I should be having this to be 9, 2 log of 5 base 9 plus, 3 log of 3 root 6 raised to power 3. Here should be 2 can cancel 2. I'll be left with 7 log of 7 log of 25 base 7, then minus of, then this one should be giving me 5. I'll be having this as 1 over 2, that is 3 times 1 over 2, that is equals to 3 over 2 log of 6 base 5. Log of 6 base 5. This is all we have for this. So, if you are given such thing like this, I can easily write this. Now, this one can be written as 9. This my 2, we turn it back to the top. I'll be having log of log of 5 into square base 9. If you apply the law of logarithm, these 2 should be returned back using the law of logarithm. Now, I'll be having plus 3 log of root 6, everything raised to power 3. Now, I can easily write this also. Let me return it back. Log of 25 base 7. But this is minus. When we get here, this one will return back to this place. I'll be having 5 log of. Now, this is. I should be having this as 6 3 over 2 base 5. I want to explain something here. I have 6 raised to power 3 over 2 in indices. If I have 6 raised to power 3 over 2 in indices, it simply means these 2 become the root of 6, square root of 6, everything raised to power of 3. Now, I'm going to replace this with the same thing. I'll be having square root of 6 raised to power of 3, which is for this. I have something of this kind. Now, applying your law that if I have a log x base a, since if you check here the base of this log and this base is equal, I can easily eliminate this log by saying everything equals 5 squared. The same thing apply at 3 base, this is base 3, this is also base 3, then this one is what? Plus root 6 raised to the power of 3. This multiplied by this. This one will simply give rise to 25. Why this one will be giving me something of this kind? This is 5. This is 5 raised to power. This 5 raised to power this. Base 5 and the base 5 there. That thing should be giving me minus root 6 raised to power of 3. We're getting something of this equation here. Now, this is what I'm going to get here. Now, you know my 5 square is going to give me 25 plus my root 6 raised to power 3 multiplied by 25 minus root 6 raised to power 3. Now, we're getting this kind here. This is difference of 2 square. I have this is difference of 2 square. I have 25 plus this and 25 minus this. I can simply multiply this directly. You see, in mathematics, if I have a plus b into bracket a minus b, this can simply what? Solve by saying a times a square, b plus times minus minus b times b squared. That's what we are going to be getting if I'm using that. The same thing applies to this. If I want to solve this, then I need to multiply this times this. Then this times this. Now, if I'm going to multiply it, 25 multiplied, so I should be having 25 multiplied, 25 by 25 should give rise to 625. 625, I have 625. Yeah, this times this 625 plus times minus should be 625 plus times minus is minus. Now, in this case, I have root 6 times root 6 cube. Root 6 cube times root 6 cube is simply going to give us, this is how I multiply it. If I have root 6 raised to power 3, and I want to multiply with another root 6 raised to power 3, it is simple. Just go straight by saying root 6, using the law of indices. This is simply root 6 times root 6, everything raised to the power of 3. Root 6 times root 6 is going to give me 6, everything raised to the power of 3. Are we together in that manner? Now, if I have root 6 times root 6 raised to the power of 6 plus 3 should give rise to 216. Now, in that case, I can simply solve by using this. I have 25 times 25 is 625. This times this is simply 6 raised to the power 3, which is 625 minus 216. 625 minus 216 is going to give us, I have this minus this will be equals to 409. That's the solution to the problem. See that what it is quite easy. Although it looks somehow that when you see that the student will say, oh, wow, how can I solve all this nonsense kind of question? It looks difficult in our eye, but it is quite easy to solve. By just applying the simple laws of logarithm. This is the first law, which is the change of base law, and this law is used to transform power into ordinary base. That's what we normally make use of this law for. And this, now you can also apply the simple other laws that we can apply on it, like for example, your normal power law and the like. Thanks for watching the video. Please subscribe to my channel and like my videos. Also, give us a thumb up. Thanks.